Good day, grade 7.
I am your teacher, Marie.
Good day, grade 7. Now we're going to discuss a new topic. Let us enjoy watching while learning.
Multiplication and division of polynomial. In the process of multiplication and division of polynomial, you need to apply law of exponent. Remember that exponent tells how many times the base will be multiplied by itself. Any number a raised to n, a is the base and n is the exponent. For example, we have 5 cubed means 5 times 5 times 5, which is equal to 125. In x times x times x times x times x, the variable x is multiplied by itself 5 times. Hence, you can write it as x raised to the 5th power. Here, the base is x and the exponent is 5. Exponent. The exponent of a number says how many times to be used the number is multiplied. 8 squared. 2 is the exponent, or it can be read also as the index or power. Then our base is 8. In the given example 5 cubed, which is equal to 5 times 5 times 5, and it is equal to 125, 5 cubed could be called 5 in the 3rd power, 5 to the power of 3, or simply 5 cubed. Sometimes the use of this symbol that we can find in the number 6 on our keyboard, as it is easy to type, so we can write is 2 raised to the 4th. So it means we have 2 times 2 times 2 times 2, which is equal to 16. Negative exponent. Negative. What could be the opposite of multiplying? So we have a raised to negative n, which is equal to 1 over a raised to n. So we divide the number each time, which is same as multiplying by 1 over the number. Example, 8 raised to negative 1, which is equal to 1 over 8, or in decimal point we have 0.125 in the thousandth place. We can continue like this. For example, we have 5 raised to negative 3, so it is equal to 1/5 times 1/5 times 1/5, which is equal to 1 over 125, or in decimal point we have 0.8 in the thousandth place. That last example shows an easier way to handle negative exponent. First, we have to calculate the positive exponent, a raised to n, then take the reciprocal. To get the reciprocal of a number, we divide 1 by the number. Here are the other examples and the given reciprocal of the positive exponent and the given answer. What if the exponent is 0 or 1? If the exponent is 1, then you should just have the number itself. For example, 8 raised to 1 is equal to 8. If the exponent is 0, then you get 1. Example, 8 raised to 0 is equal to 1. But what about 0 raised to 0? It could be either 1 or 0. So, it is indeterminate. Law of exponent. Exponent have its own rule in perform mathematical operation. In simplified terms containing exponent, law of exponent can be applied. Consider the simplifying 5 cubed times 5 raised to the 4th power. Using the definition of exponent, 5 cubed times 5 raised to the 4th power is equal to 5 times 5 times 5. Then we're going to multiply it in 5 times 5 times 5 times 5, which is equal to 5 raised to 7. Therefore, 5 cubed times 5 raised to the 4th power is equal to 5 raised to 7, just adding the exponent. This rule is all about product rule. To multiply power of the same base, add the exponent in symbol for any number a and positive integer m and n is equal to a raised to m times a raised to n is equal to m plus n. Now, let us study the pattern of the questions below. We have 81 divided by 9 is equal to 9. Then 729 divided by 27 is equal to 27. 81 is equal to 3 raised to the 4th power. then 9 is equal to 3 squared. Then 3 raised to the 4th power divided by 3 squared is equal to 3 squared. Then 729 is equal to 3 raised to the 6th power. Then 27 is equal to 3 cube. Then 3 raised to 6th power divided by 3 cube is equal to 3 cube. This pattern above leads to us a quotient rule. Quotient rule is if A is any number except 0 and Mn and M minus N are the positive integers, then A raised to M over A raised to N is equal to A raised to M minus N. Here the example. Letter A to the 5th power divided by A cube is equal to A times A times A times A over A times A times A. So just using cancellation, so we're going to cancel the 3A in our numerator, then the 3A in our denominator. Therefore, we have A times A times A, or it is simply, we have A to the 5th power over A cube is equal to A raised to 5 minus 3, then we have A squared. Letter B, A cube over A cube is equal to A raised to 3 minus 3 is equal to A raised to 0. Therefore, A raised to 0 is equal to 1. Next, letter C, A squared over A raised to the 4th power. So we have A times A all over A times A times A times A, which is equal to 1 over A squared. It is similar to A squared over A to the 4th power. Then it is equal to A raised to 2 minus 4. Then it is A raised to negative 2. So we have the exponent is negative 2. Therefore, we have 1 over A squared. Let us consider expression raised to power as shows below. Number 1, we have 5y squared. So 5y squared is equal to 5y times 5y. So we have 5 times 5, then y times y. So 5 raised to 1 plus 1 as exponential expression, then y is equal to times y raised to 1 plus 1, as also we have the exponential expression. So 5 raised to 1 plus 1 is equal to 5 squared, then y raised to 1 plus 1 is equal to y squared. Therefore, we have 5 squared times y squared is equal to 25y squared. Number 2, we have 3x over 4y raised to 3 power, or 3x over 4y cube. So we have 3x times 3x times 3x all over 4y times 4y times 4y. So we have 3 raised to 1 plus 1 plus 1 because we have this base of 3, then x raised to 1 plus 1 plus 1 with the base of x all over 4 raised to 1 plus 1 plus 1 times y raised to 1 plus 1 plus 1. So we have 3 cube times x cube all over 4 cube times y cube. Then 3x over 4y cube is equal to 27x cube over 64y cube. The two given example will be considered as an example of these two rules. We have first, power of product rule. If a and b are any numbers and n is positive integers, then ab raised to n is equal to a raised to n, b raised to n. Another rule is the power of quotients rule. If a and b are any number and n is positive integers, then a over b raised to n is equal to a raised to n over b raised to n, which is b is not equal to 0. Now let us try this example. Suppose we have 3 squared raised to 4 is being simplified. So using the definition of exponent and the first law of exponent, we have 3 squared raised to the 4th is equal to 3 squared times 3 squared times 3 squared times 3 squared. Or it is equal to the base of 3 raised to 2 plus 2 plus 2 plus 2. Therefore, we have 3 squared raised to the 4th power is equal to 3 raised to the 8th power. You have noticed that being simplified expression results from just multiplying the exponent. This lead to us of another law. Power of a power rule. If a, m, and n are real numbers, then a raised to m raised to n is equal to a raised to mn. From the quotients of power, if a is not equal to 0, then we have a raised to m over a raised to n is equal to a raised to m minus n. Suppose m is equal to n, then a raised to m over a raised to m is equal to a raised to m minus m. So we have a raised to 0. A number divided by itself is 1. Hence, a raised to m over a raised to m is equal to 1. Therefore, a raised to m minus n is equal to a raised to 0. Or we have a raised to 0 is equal to 1. This suggests the following definition. We have the zero exponent. If a is any number except 0, then a raised to 0 is equal to 1. Again, from the quotient of power, we have a raised to m all over a raised to n is equal to a raised to m minus n, which is a is not equal to 0 and m is greater than n. So m minus n is less than 0, says that n is equal to 5 and m is equal to 2. We have a squared over a to the 5th power, then it is equal to a raised to 2 minus 5, or it is equal to a raised to negative 3. Using the definition of exponent, a squared over a raised to the 5th power is equal to 1 over a cubed. Therefore, we have a raised to negative 3 is equal to 1 over a cubed. Another rule is the negative exponent. If a is not equal to 0 and n is a positive integers, then a raised to negative n is equal to 1 over a raised to n.